Good morning. I hope everybody is enjoying the conference. I'm Bruno, as he said. I'm an iOS developer. It's been almost 4 years I'm working with iOS now. I only develop native iOS apps, and recently I've been digging deep into ARKit, and it's amazing. I work for a company in Budapest called Supercharge. We are a software studio there, and we do really nice projects. Unfortunately, we never had the opportunity to work on AR, but then they give me a lot of time to research on what I have interested about. Okay, so today I'm going to talk about ARKit, as I told you. So I actually want to talk about the 2.0 version of ARKit. This framework has the 2.0 version released now in the latest dev.dc. And this is a guy that I met, Oscar Falmer, and he did this conception, which is something that's I think it's a concept that's gonna be pretty useful when we have AR glasses on the market. It's pretty cool. And the ARKit 2.0, first I want to make a question. How many of you, please raise your hands, who ever worked with augmented reality ARKit? 1, 2, 3, 4. Okay, 5. Okay, so I have a recap here. This is the agenda for today. We're gonna do a recap on the ARKit in general, and then we're gonna see the new stuff. We're gonna see what is USDZ, AR Quick Look, Occlusion, 6D AI, which is a SDK that is very cool. It's available for beta testing. And then on the end, we're gonna talk a bit about Core ML with ARKit as very, very tiny, like nothing compared to what you just had now. Okay, so quick recap on ARKit. ARKit is the framework that works with augmented reality on iOS and uses a technology called Visual Inertial Odometer, VIO. This basically gathers together, I don't think it's right, gathers the camera data with core motion features, so pedometer, gyroscope, and accelerometer, so see how far you went from the point that you started. Gathers feature point around you on the wall, so on the surfaces that are not so smooth. So for example, in this gray wall here wouldn't be so good, but for example on the wall in the back would be awesome because it's full of features. And then with all these informations, you can do the scene. We can set up a scene with nodes, with geometries, and for every node you can add actions to it, and then you can have really nice experiences as we are seeing nowadays with everything that is being released on the market. Okay, so I'm gonna be a bit more slow here because not many of you have worked with it already. So every scene has a root node, and from the root node you have child nodes. And once you add an action to it, once you add an action to a node, all the child nodes inherit. So for example, this example is the best for me. When you have like a solar system, if you want to do a solar system, this is one of the most basic examples of ARKit. If you have to put everybody on a child node of the sun, because everybody will be around the sun, and then you put the rotation for the sun, and everybody will be rotating because of the rotation that you applied to the parent node. So that's the concept that child nodes inherit actions from the parent nodes. Every time you want to set textures to it, whether is it reflecting or diffuse or specular is like reflective, you go for the first material. The first material is just a init method for the material property of the node, of the geometry actually, sorry. The anchors have the positions of the features on the object, and then the SCN actions, as I said, that you can apply, for example, rotation or movement or anything, or fading in, fading out. A couple of requirements to use this framework is that you need to have iOS 11 minimum, and phones with A9, A10, or 11, and now with the latest WWDC, we saw that there is a A12. And that means that you need iPhone 6S and newer versions, not 6, I guess. And then also to use it, you need the camera. So you have to put on your police file string privacy for the use of the camera, and then you have to set a message for the user saying like, hey, please allow me to use the camera because I wanted to show you some cool stuff here. Okay, so once you understood all of this, the best part that we're going to use also on ARKit 2.0 is the AR scene view delegate. Because these delegate methods, when we implement them, these methods are going to get called every time we update the scene with something. So for example, when I start my experience in ARKit, and then I go around, the scene kind of understands that it expanded, so it's more feature points to it. And then these methods did add, did update, did remove, they get called all the time. And with this, you can interact with your scene. So for example, if you go far away from the point that you started, you can reduce something or you can interact. So for example, Pokemon Go, I don't know, an example. You go far away from the Pokemon, and then the Pokemon starts to cry, I don't know. No, just an example. I never played actually, so I don't know. So you have many types of anchors. So you have plane anchor, you have face anchor, you have image anchor, object anchor. We're gonna talk a bit about some of them now. But basically, when the delegate methods are implemented, you can check which is the anchor that you are finding. So for example, if your app is based on face, so you can check if it's a face anchor. And then, for example, there are many facial features, like for example, the position of the eye, or if the eye is blinking, or if the left eye, or the right eye, especially now with the ARKit 2.0. The extent is the size of the plane or of the anchor. And all these informations you can get when you implement the delegate methods. Other angles is just a way of rotation. It's just how they call rotation on ARKit. You can have 3D models, external 3D models, by drag and drop DAE, Digital Asset Exchange, files extension, into your Xcode. And then we have a couple of tracking technologies. So we have world tracking technology, we have orientation word orientation or something like that. And now we have image tracking, we have object scanning. We're gonna go also on this further. But the point here is that each one of these tracking technologies, they are more prepared for some situation. So once you understand all of them, you can see what is better for your app or not. Okay, so debug options is just like when you start your scene to check if there is something there. They put like this small, I think you have seen already on Twitter or some examples. You've seen these small yellow dots on the screen, normally on the surfaces that are problematic or not perfect. Okay, let's go further. ARKit 2.0 comes with some really nice cool stuff. Persistence and sharing, which is basically you kill your app, and then when you restart it, you can restore the session that you had. Actually, the session is not restored, but the map that you had was restored. Sharing also is having, for example, multi-peer connectivity, the framework that Apple has for Bluetooth, and also on the Wi-Fi actually. You can use multi-peer connectivity to share your roadmap between the users of the game or of the app, and then that's why it's sharing. Environmental testing basically is like you have nodes on the scene, and these nodes, they have reflections from the real world. So for example, if I put a ball here, it's gonna have a reflect of the reflector. I don't know how to call this. Projector. Image tracking, it's a bit different from image detection, but I'm gonna show you both of them so you understand better. Object detection or object scanning also, how do they call it? It's basically like literally scanning an object to create a reference, and then you can share this with other apps. We're gonna get there as well. Enhanced face tracking is just, like I said before, just like more information about the anchors that you have on your face. Okay, so the first thing of persistent and sharing is the world mapping status. When you don't have a camera, or you are on the simulator, or you are still starting the app, you have this not available status. And then when you start, the phone is still tracking on your scene. Like for example, your phone stopped here, but it's still tracking the box here, checking the points, and then normally these apps, they ask you to move around the scene. It's limited. And then once it's done, it goes for mapped straight, or it goes to extending. And then it's gonna go infinitely on this cycle. Every time that you move to a new part of the scene that the app didn't recognize yet, you're gonna go on standing, and then mapped, and then you go to new areas, and then you go to limited, extending, and mapped. And then it goes like this. To persist your scene, to save and to load are the exactly opposite processes. You just have to get the AR world map anywhere on your app. So you just get the session. Your session is a property there, up there on the app. And then you get current world map. And you set a URL for it. So where are you going to save it? Using File Manager. And then you archive it into the URL that you saved. Now you have to save this URL, because then when you want to load it, you have to do the opposite process. So basically, you're going to get the archived world map from the URL, unarchive it, and then you set as initial world map. That's how you set up scene that was previously, that you had previously. Okay. Environment and test string, like I said, is just a reflection of the real environment. So you can set these two properties, for example, roughness and metalness, to check how much reflective it will be, the surface of the material that you are working with. This is an example, for example. They are using AR world tracking configuration. And then you set the property environment text string for automatic. And you just added a node here, and then with the geometry of a sphere. So it's a ball. I created this material here, which doesn't have any texture yet so far. And I'm using Lightning model physically based, because it can be physically based or image based. Image based, it's, for example, if you apply a texture to it, you're gonna have the reflection of the own image. It's a little bit complicated to understand that. But physically based is the world around you. So then you can set from 0 to 1 how much metalness you want on that material, or how much roughness you want on that material. And then you just set to the first material, like I said. I missed the content property here. Image detection we already had. But then you can see that that's why it's different from image tracking, because it can get the idea, it can get the extent of the model, but it doesn't track. So once it's done, unless you keep updating it all the time, doing interpolation. So for example, I got this scene here, and then I moved the paper, and then I got the new position, and then I'm gonna send this guy to that position, but it doesn't track you. So you would have to do like sort of a hack to use it. And now ARKit 2.0 has it like out of the, already done for you. To use image detection, all you have to do is drag and drop a resource image for you. So like, I don't know, I want to track, like the Oscar did on the card. So you take a picture of the card and you say the dimensions on the real world. You create on your asset AR resource group. And this is gonna be your AR reference image. So the card, for example. And then all you have to do here is get the reference image, and then on the configuration you set detection image to the image that you said that you wanted to go. And here is the delegate method that we talked about earlier. So this is for the scene delegate, AR scene delegate. And then all you have to do here, because it's gonna give you nodes all the time. So all you have to do here is check if this node is a AR image anchor or an object anchor or any other type of anchor, face anchor or any other type of anchor. And once you have that, you have the center, the extent, and the position and everything. So for example, if detected an image that you wanted to track, so for example, the card, now you have where the card is, the size of the card, the orientation of the card, if it's positioned like this or like that, then you can apply transformation matrices to it to get positions around and everything, which is super cool. Now image tracking, that's basically the difference between image detection and image tracking, because it's gonna update the position at all times. And the only difference here is that we are not using AR world tracking anymore. We use the AR image tracking configuration for it. And then you can track multiple images simultaneously, which is also something new. But besides of that, it's the same thing. Object scanning, it's the other topic of the ARKit 2.0, which is new. So it's a little bit complicated to do it. It's also another type of configuration. So not anymore world tracking, not anymore image tracking. Now it's object scanning configuration. And Apple made this, this is the example app from Apple. And you can download it, and because the whole idea here is that you're gonna generate a .ar object. I think that's the extension. Yeah, .ar object. And if you want your app to be a scanner, okay, you can implement the function. But then you're gonna have to somehow make the user, that's gonna be like quite a lot of work. You're gonna have somehow make the user to set the center of the object that you want, the extent of it, set the whole, every property for it. Because that's what it calls the bounding box. And if you use this example from Apple, for example, you can pre-scan your objects and then send it via AirDrop or iCloud, for example, because it doesn't really matter if you scan there or not, you just can share the AR reference object. And the same we did before with the image anchor or with the face anchor, with the every other type of anchor, we would do here with the object anchor. So all we have to do is implement the delegate method, and then we check the anchor. If it's a type of AR object anchor, then we can do anything we want. And oh fuck, I did the wrong tracking configuration here. And instead of detection images, we have detection objects here for reference objects. Okay, so sorry about that. USDZ is a new extension from Apple because they had this extension already on Pixar, which is called Universal Scene Description Zip. And basically this extension of file that you can share also on Messenger and files and every other app that you have native on your iOS. You can have also something called AR Quick Look with it because Apple. Oh, by the way, also you can get on your Safari. You can get into Apple's website, and they have like a list of USDZ files that you can check. This is a native screen. So for example, nobody did this app here. Someone did probably this model here. So someone did this USDZ file, but nobody did this. For example, these buttons here, because this is a native thing from iOS 12 now. So once you have your model, you can share with everyone else. So you have your USDZ file. So for example, I want to sell this pointer here. So I just create the 3D model for it. I transform it into a USDZ, and you can do that by installing Xcode 10. You have on the command line tools, you have this tool called USDZ converter, and then you can pre-model it in another tool, like for example Maya or Autodesk. I think in some sort of Autodesk suite. And then if you export on any one of these extensions here, you can convert into a USDZ by using the USDZ converter. But also there are some easier tools if you don't like to use the terminal, for example. And then that's cool. You can share, and then for example, you can check just the object here, and you can put it on the real world if you just put it on AR. Okay, occlusion is not something new also, but it's something that really makes a difference on AR apps. And that's why I chose to talk about it, actually. Occlusion is the effect of obstacle in augmented reality. So basically, for example, if you have, I'm going to repeat this. If you have a ball here, and this wall, imagine that this is a door because you cannot see because it's too bright, but this is a door. So imagine that there is a door here like 1 or 2 meters away from you, and you kick the ball, the virtual ball. The ball should touch the door and comes back, but then the app didn't detect the door yet. So also another situation that it would be problematic in occlusion solves it is when you kick the ball and it goes behind the wall, behind the door. So you shouldn't see it because it's behind the door. So occlusion comes to solve that. Basically what you're going to do here is put an invisible node here, and you're going to say, hey, there is something there. You cannot see it, but there is something there. So when I kicked it on the door, it goes back, just like the interaction with two objects. And there is a trick called the rendering order trick, because it's obvious, if I see the door, this node is invisible. But then why, when I send the ball behind the door, I cannot see the ball if it's invisible? Because that's a trick of rendering order. Depending on the rendering order of these two objects and the transparency of both of them, you can have one invisible against another or not. 6D AI, it's a SDK. It's a company, and they have their SDK available for beta testing. So whoever wants to try, it's really cool. And the really cool thing that they're doing is this thing called meshing. It's like this mapping of the high. You got it? Like for example, it's difficult because, for example, if I give you 2 days to do this, you're not gonna do it, because basically the easier things that you have to do here is like plane detection. But check this dog, he's not plane, you know, like probably there will be like a table on top of him, but not like if the money falls on his belly, it slips away, you know, and this is amazing. This is the meshing that they're doing, and there's a lot of computer vision involved, and you can save a lot of time if you use their SDK. Another thing that they do here is the rendering example. So for example, you see that when the ball falls here, they disappear because he's doing this rendering order trick. That's also occlusion. And I think it was pretty quick, actually. This is my last topic here. This is something that I did recently, which is CoreML. I tried to put together CoreML in ARKit. And I really like this movie. It's called Minority Report with Tom Cruise. I tried to reproduce this scene using the ARKit and CoreML. It didn't work. It didn't work. I said, okay, you know what should I do to reproduce that scene? I need holograms. Let's see it again. I need some holograms. I need some super modern glove. And I need Tom Cruise. I cannot have any of them. Holograms, I don't know if they exist, or if they do, how many millions they cost. Gloves with this gesture recognition, man, I'm an intern. Tom Cruise, I call him, but he was sick this morning. Then no, I said, you know what, let's do some substitutions here. Holograms can be easily replaced by augmented reality. And for these gloves with gesture recognition, I don't even have to buy gloves because I can train my model with my hand. And then I can set gestures with machine learning. And Tom Cruise, there was no way. Okay, so the plan is, I'm gonna create a data set. I know that the guy was here now. He's here in this room. He was just saying a lot of things about machine learning, so if I say something wrong, please forgive me. You're gonna create a data set, basically, and there are lots of ways to do that. And then we train a model, train a classifier, and we're gonna integrate recognition into our app. We're gonna use this model to compare the images that the camera is seeing. So basically, I'm gonna train this model with a bunch of photos of my hand open and my hand closed, or my hand like any other gesture. And when I apply this model, this classifier into our app, basically gonna check, hey, this image that the camera is seeing right now, it looks like the hand open or the hand closed. If you have a bad model, you're gonna have bad results. But that's with it in life for everything, I guess. And then we integrate recognition, and then depending on the result of recognition, so for example, hey, we have 100% confidence that this is an open hand. Then we're gonna act on the AR according to what we expect for the open hand status. One way that I did this to create a dataset, because datasets can be very annoying if you wanna make them more precise. You have to do like a lot of pictures, like a lot. So one way you can do this is using the iPhone burst. So basically you're gonna put on a camera, and then you're gonna hold the camera, and you're gonna hold the button of taking to shoot the photo, and then you're gonna take like millions of photos. And that's a problem if you wanna pass it by WhatsApp or AirDrop or anything. But if you're passing it through Photos, then you can just export everything, and then you just send it straight to your model. Training a model, it's easy for some people, not for me. So there is this tool called Custom Visual AI. It's a tool from Microsoft. I'm not a big fan of Microsoft. I respect them, but it's for free. It's easy. All you have to do is drag and drop your images into this website. You create your account there. All you have to do is drag and drop your images into this website, and you're gonna tag the images that you're gonna classify the images. So basically, you're gonna put 200, 300, how many pictures you want of your open hand. So in different light conditions, because you have to be the last biased possible to create a good classifier. So you're gonna put lots of pictures in many kinds of ways, close, a bit open, and then you're gonna tag all these pictures as open hand. And then you're gonna do the same for the closed hand, and then you're gonna do the same for peace sign and everything. And one of the good things about this custom visual AI is also that they export directly to CoreML models. So some other platforms you have to convert because they export in one way, and then you have to convert it to CoreML. And for me, it's easier than putting Turi Create or other platforms. I don't know, I'm just lazy. How do we integrate it on the app? We use Vision, the framework that we have already there. We don't have to, it's not an external library, so it's already there. And we can do this in two ways. Two stupid ways, actually. Trying to recognize all the frames recursively, that's 60 frames per second. You're gonna call a method 60 frames, you're gonna call it a method 60 times per second, and this is not gonna go well. I don't think it's gonna go well. Or you can do the session delegate methods, which is also 60 frames per second. So both ideas are awful. But, you know, just try it if you want to try it. So even infinity recursion or 60 frames per second calling on the delegate methods, put it on a serial queue at least, because then it's not going to block your UI. And to act with AR, of course, we're going to use what? Someone? Nobody? Nobody want to risk? Of course we're not going to use core data. Why would you use core data? ARKit, of course. But we need to go deeper. A bit more inside with the AR, what we're going to do here, we're going to use a UI web view. We're going to control the scroll with it. And we implement the delegate methods for the AR scene view delegate or for the AR session delegate. So every frame that the scene is rendered, we can get call and say like, hey, do you want to change something? Are you checking something? We have a new frame. Can you check if the hand is open and is appearing or not? And the machine learn part is that we're going to have the core ML model from Vision to set up the model that we exported from custom Vision UI, because this is just when you generate the model, the file, all you have to do is drag and drop into your project navigator. Once you have that, I'm going to show you on the next slides that all you have to do is like, I don't know how, but Xcode just recognize it. And you're going to create a bunch of requests, and you're going to dispatch into the serial queue to check if this is a hand or not, if this is an open or closed hand. What if I told you we have to go even deeper? So we have to really look for code. I'm going to go with you line by line what I'm doing here. So first of all, I went to my storyboard, whatever, and then I put the AR scene view there. I connected my delegate here, my outlet, sorry. I have here my serial queue. I have an array of requests, and I have a UI web view with some weird frame here. I created these three functions here, setup AR, setup ML, and then I want to call a loop function. With setup AR, I'm doing something like I put a tap gesture recognizer to run to start the AR. So for example, I run my app, and then I want to start the recognition or start something else, and then I created this tap gesture recognizer. With this setup ML, what I'm doing here is just getting the name of the model. So for example, when I exported my model from the custom Vision AI, I named it example underscore model. And I don't know, again, I don't know why, but Xcode recognizes. So all you have to do here is call it as a method and then dot model. And OK, so once you have that, all you have to do is set a core ML request, passing the model that you use, so the custom Vision AI model. And I created a different method for the completion handler, which is on the next slide, I guess. So once I tap this, I put my UI, once I tap this scene, I put my UI web view on the scene with some URL there. And this UI web view gonna be contained onto a plane, which makes a lot of sense because it's a plane, it's a 2D. Here I'm just setting the positions. What else? And I'm just rotating it to 0 because it was, for some reason, it was badly rotated. And then, again, I get the root node from the scene, and then I add a child node to it, which is our browser plane, which is a SCN plane node with the UI web view. Now, the loop function basically is calling on my serial queue to update the core ML. So basically checking if the hand is open or hand is closed, and then calling the same method again forever. This is awful. This is horrible. If you do this on your work, your boss is going to fire you. And don't tell that I told you to do this. When you call update core ML, basically what we're doing here is getting the section current frame, because it doesn't, the current frame probably is a AR frame property, AR frame object, and you have to go for a CI image to call this image request handler. So you get the capture image, which is a UI image, and then you turn it into a CI image, and then you try to perform the request. And once the handler is called, what we're gonna do here, we're gonna separate the whole results of it. It's like a bunch of, it's like a big string between the confidence, I think it's a dictionary actually, between the confidence and for every result that you have, for every tag that you have. So for example, open hand. The confidence of open hand on this image is 0.2. The confidence of this of having a closed hand on this image is 0.1. So we're gonna separate all of this here. It's just like some string job here, so it's not a big deal. And then, since we're gonna update the UI, we go back to the main thread, to the UI thread, And then we separate everything. We already had the results from it, from what we did on the string job before. And now here I have my top prediction. If it's hand closed, I act on it. So I scroll up, or I destroy, or I change the website, or I do anything I want. And if it's the hand open, which is the other tag that I trained my model, I just do something else. And this was the result that I had. Was not like Minority Report, but it was something. And that's it. Thank you very much.